Hello and welcome to today's webinar entitled Fast Data and Real-Time Analytics in Telecom, Enhancing Customer Engagement. My name is Peter Viscuso and I'm with VoltDB. I'll be the moderator for today's event. Before we begin, I'd just like to go through a few housekeeping items. This is an event with On24. There are a lot of people on the call, so the call is going to be muted. You might experience a slight delay when we transition between slides. The presentation is going to last about 40 to 45 minutes, and there'll be time for questions at the end, and we ask you to use the On24 chat window to enter in questions. I also wanted to let you know that everyone who's registered for the webinar will receive a copy of the recording, a link to an email with a copy to the recording and the presentation, which will be available in a few days. So you can look for that. So we're going to get going. I'd like to introduce today's speakers. Very happy to have with us today from Flytxt, Prateek Kapadia. He's the CTO. He manages Flytxt's technology roadmap with a strategic focus on R&D and intellectual property creation and protection. He has 15 years experience across mobile network and application innovation in wireless and data network management, as well as cryptography. In his last appointment with the Center for Excellence in Telecom at IIT in Mumbai, Prateek contributed to the IEEE 802.16m standard and co-invented a mobile social network application platform. Previously, Prateek held a technology lead position for the packet data services at Reliance Communications and developed cryptographic software at Algorithmic Research Limited in Israel. Also with us today, Ryan Betts, the CTO at VoltDB. Ryan was one of the initial developers of VoltDB's commercial product. He values his opportunity to closely collaborate with customers, partners, and prospects to understand their data management needs and help them realize business value out of VoltDB and related technology. Ryan's an alumnus of Worcester Polytechnic Institute, and we're happy to have both Ryan and Prateek with us today. Let me just go over the agenda. A quick introduction, just a brief overview of VoltDB. I'll hand it to Ryan, who will talk about fast and big data, the ecosystem and architecture. And then Ryan will hand it over to Prateek to talk about Flytxt and their use of VoltDB in their service offerings for real-time on-trigger decision-making. Prateek will also cover a case study, and then at the end we'll wrap up and do Q&A. Quickly, just a brief overview of VoltDB in case you're not familiar with the company. It was founded in 2009 by Mike Stonebreaker. Some people call Mike a database luminary because he's got such a prolific track record in the database world, starting with the creation of Ingress, then Postgres, Streambase, Vertica, then VoltDB. A large number of innovations in the database world, pretty much new technology created at every major kind of technology inflection point. VoltDB has customers throughout the world, U.S., Europe, Asia, and South America. We've been very fortunate to be experiencing significant growth with the adoption of our technology. Flytxt being one of those adopters of our technology, and we're very excited to have them here to talk about their use of it. VoltDB is an in-memory, scale-out SQL database with terrific performance. There's information on our website about our world record performance with the Yahoo Cloud Services benchmark. We're also very excited that Gartner included us in the Magic Quadrant for operational databases for the second year in a row, and information on that is available on our website as well. We've got offices in the Boston area, Bedford, Mass., as well as on the West Coast in Santa Clara, and locations throughout Asia. With that, I'm going to turn it over to Ryan.
Thank you, Peter. So today we're going to talk about fast data and big data, how to combine fast data and big data to build big data applications that have a business value. When you start to think about the tasks at hand to build a complete data at scale architecture, you quickly realize that there are four main tasks that architecture has to resolve. You need to be able to collect data. You need to be able to explore the data that's collected. Sometimes we call that data science, but you're looking for some hypothesis or pattern or something of interest. Once you've found that, you want to formalize that exploration as a repeatable analytical process, analyze the data, and then finally, in order to derive a business value from that, you need to be able to build an application or a process or some activity off of the analytic result. And so you collect data, you explore it for a hypothesis, you analyze it in some formal repeated way, then you need to be able to build an application off of the result of those analytics. That application is usually what's creating value for you. Next slide. So what kind of an architecture can accomplish all four of these activities: collect, explore, analyze, and act? Commonly, what we're seeing are architectures that separate two portions of this, the fast and the big. On the big side, we have tools that are responsible for storing large volumes of information and that are responsible for enabling interactivity, exploration, and analytics against that volume of data. On the fast side, we have tools that are designed to process data at ingest, to participate in the collection phase, and that allow you to build real-time applications for systems of engagement, authorization, fraud, or policy enforcement. The applications that are built against the analytics derived from the big side, deployed in real time to improve your customer experience, to offer opportunities for cross-sell, upsell, and personalization. Next slide. The big data side has naturally matured first. I think this makes a lot of sense. You can't start building applications on top of these analytics until you have performed the exploration and the analytics phases themselves, and those necessitate the big data side of this architecture. So I want to focus a little bit on the newer side of this, the emerging side, the fast data side. What are the requirements for the fast data side of this architecture? The fast data component needs to be able to ingest and interact against streams of inbound data. We're talking about streams of data that are arriving from machine-to-machine applications, Internet of Things deployments, or large social deployments. Telco is another great example of a source of real-time, fast incoming data that you're trying to build an application against. So the first requirement of the fast data side is the scalability, reliability, and performance to process an almost unlimited stream of incoming data. As you're processing that data, there are a few key things that you need to be able to do. Most importantly, you need to be able to make per-event decisions. As you receive each event, you need to be able to combine the current context, the immediacy that surrounds that point in time, with the analytics that you've done in the past to create some optimized decision. That could be an authorization, a policy enforcement, an opportunity to personalize. But effectively, you're taking the learnings of your big data side, the context of the fast data side, and you're relying on your fast data architecture to be able to produce a per-event decision in real time. As you make those decisions, you need to be able to integrate the results as well as the incoming stream into input into the big data side. So you need to participate in this collection process. As data is being collected, there's often the necessity to enrich it, to add metadata, or to denormalize it for eventual storage into your big data side. And so another activity that's required at the fast data side is this real-time ETL, or real-time data ingestion. And finally, it's important that we have operational transparency into these real-time data streams. That requires that your fast data side can perform analytical operations against these streaming inputs. Real-time analytics is another core requirement of the fast data side. Next slide, please. So let's stop and look at the fast data, big data split from a slightly different perspective. Let's look at some of the example technologies and some of the example applications that rely heavily on one side or the other of this particular architecture. On the big data side, some of the example technologies in use include the Hadoop ecosystem, or a lot of times columnar OLAP systems, like columnar warehouses. And the example applications here are pretty familiar. We're calculating perhaps user segmentation or pre-scoring some algorithm across a large user base. We're looking for seasonal trending or clustering, or we're building large recommendation indices. These are all some of the classical use cases of the big data side. Next slide. On the fast data side, we're building applications that are often about user engagement or systems of engagement. And there are really a few different technologies being proposed for the fast data side. Some of them take a streaming point of view. Others, like VoltDB, look at the fast data side as necessitating the ability to make decisions against events, and we propose a database technology that's capable of transacting against these streams in real time. The applications on the fast data side include personalization, serving recommendations, real-time alerting and alarming, operational monitoring, real-time data enrichment or real-time ETL, and high-throughput authorization. All of these applications running against real-time streams of data being generated by some large distributed source, writing the application against that stream, and then supporting the collection and ingest of this stream into the big data side. Next slide. A common example of where you derive value by combining big data and fast data is looking at a real-time scoring application. So say, for example, that you have a large user base, and as they activate or as they engage with you, you want to be able to personalize or optimize their experience in real time. One common approach to that is the segmentation process. On the big data side, you would generate a user segmentation report. You would look for some way that you could classify your users by type or activity or value. That's an analytic operation that runs considering the vast history that you've collected about all of your users. The result of that activity is a report, essentially a classification of your users. If you cache that report into the fast data side, you can use that pre-calculated segmentation in real time as your users engage with you to optimize the experience that you produce for them, to tune the experience, to offer them an appropriate activity, to offer them an appropriate product to purchase, or to perhaps authorize or encourage access to some portion of your system. If you look at the two different profiles, fast and big, you can see that the activities are very different. On the big side, it was about how much historical data could you capture and analyze in order to produce this segmentation report. That's a lot volume of information and about repeated analytics. On the fast side of this, it's about how quickly can you respond and make these decisions based upon the segmentation report to personalize the user's experience. That means that you're looking at frequency of request, how frequently can you make these decisions, thousands of times or tens of thousands of times a second, and can you make them quickly enough that you can make the decision in line with user experience? So can you meet the latency requirement that you can respond to the user without making the user wait or degrading the experience of the application the user's using? Next slide. Some of the common questions that I hear about the fast data side are, is the fast data side a streaming process? How do the big and fast sides communicate? Where do analytics belong? And are all of these different streaming frameworks equivalent? We certainly can't dig into these topics all today, but we've talked about these at length, and happy to answer any questions here. Working through these quickly, I would say that yes, the fast layer side does present data in a streaming format. However, it's important that you can process that streaming input as a per event system and make decisions on each event. It's important that your fast data side and your big data side communicate bilaterally. You need to be able to pass the stream that's coming in as an ingestion stream into the big data side. At the same time, you need to be able to communicate the analytical results from the big data side to the fast data side to inform real-time decisions. Analytics is a complex topic. There are analytics that are performed on both the big and the fast side. And I would say, as people delve into some of these different streaming frameworks, that they're certainly not all equivalent. Some of them are used primarily to reduce time to analytics in an OLAP-style activity like Spark, and others are used to process or enrich data as it's arriving. Storm is often used in that regard. So another way, if we go to the next slide, another way to get some of the applications that necessitate this fast data, big data split is to look at the activities that require a fast data architecture. And we really see three broad patterns in the applications on the fast data side. Applications that require fast request response for authorization or personalization. Applications that require real-time analytics for real-time key performance measurements or operational analytics transparency. and applications that are really about data pipelines, about real-time ETL and enrichment into the big data side. As you begin to architect your big data, fast data applications, I would encourage you to consider all three of these patterns and to make sure that you understand in your own context how your future architecture will accommodate these three activities: fast request response, real-time analytics, and data pipelines. In our experience, we've seen that as fast data and big data architectures mature, they eventually need to accommodate all three of these basic patterns. Go to the next slide. Another way to look at this is by looking at it from the perspective of data flow. As data is arriving, you can see that it flows from the fast data side to the big data side in three different patterns. When you're doing analytics, often the data is arriving at the fast data side. Analytics are being produced by this architecture and being consumed by dashboarding or BI users. In the pipeline case, data is flowing through the fast data side, being enriched, filtered, or correlated, and then passed to the big data side more directly for long-term archival and for analytics and exploration. And in request response patterns, there isn't just a dumb sensor or some kind of uninformed data source. Rather, you need to be able to produce an immediate response. This is often what happens in personalization applications. You have an application that's making a request that requires a response. So this is another way to look at three of the main application patterns that are built using the fast data architecture. Now, I think that I'm sure this is what everyone is actually waiting to hear from Prateek. Prateek has built a very fascinating application. I'm excited to hear him describe it. Prateek, thank you very much for joining us today. Let me hand the presentation off to you.
Thank you, Ryan. Thank you, Peter. I'm going to talk about text and how we use big data and fast data with VoltDB in order to deliver economic value to our telco customers. Next slide, please. Flytxt is a big data solutions company which operates out of the Netherlands, and our value proposition to the customer is that we create measurable economic value for our CSP partners through big data analytics. We have proven impact of between 2 to 7% of economic uplift for our customers. As we speak, we are touching over 500 million subscribers in 32 countries and across 50 plus customers. We have sold more than 100 million products using our platforms and using segments derived from big data analytics. And all these accrues to revenues of over $350 million for our customers. Next slide, please. So let me just describe a few things about how Flytxt platforms deliver this economic value to our customers. And here you see that primarily the data that is available with the telco can be used for two purposes, two ways in which that the value can be extracted or derived from this data. One which is called internal monetization, that is for the operator to use subscriber data in order to generate more incremental revenue for itself. And the other is external monetization, that is for the operator to use its subscriber data in order to transfer this value to external entities such as brands and advertising gateways in order to build new revenue streams. So overall, our expectation is that we'll make anything between 2 to 7% from internal monetization solutions and 2 to 4% of new revenue streams through external monetizations. through our platforms. So primarily, our platforms are built on master data management layer, which ingests the data from the various data sources available at the operator, and these are then data are then consumed by analytics and intelligence building engines, which is where our fast data and big data applications come in, and then finally these build decisioning logic and execution logic for taking actions on the analytics and intelligence build. So you will see that for internal monetization, we have marketing use cases. So typical use cases are revenue enhancement, customer engagement, and management of loyalty, building dashboards for the CXO organization, building applications for specific to enable upsell or cross-sell of the operator's products to its subscribers, like Smart Charge. And we supplement these services with consulting services for marketing, which will allow the operator to build the decision sciences required to get to this 2 to 7% in economic impact, and a big data managed service component that takes the onus of cleaning the data, of maintaining the data streams and the data processing correctness, and ensuring that the right insights get consumed and used for the right marketing purpose. In external monetization, we have applications such as mobile advertising, which is for a specific operator a way to securely process data and insights such that they can be consumed by third parties, that is ad exchanges or brands, without transgressing on the privacy of their own subscribers. For countries or continents or large regions where there are multiple operators in play, we build an ad marketplace for these operators, and enable advertisers to reach more than one operator through a single window. And the data that is consumed from the subscribers, this can be exposed to third-party applications as insight APIs, so that the operator can monetize directly the value for his subscriber data. So now we have seen the applications and platforms that Flytxt provides, and I'll go on to a certain use cases which we have for internal monetization. Next slide, please. So real-time marketing improves the agility for a communication service provider to respond to a subscriber action. And this is really a fast data case. So let me give you some examples. We could have real-time triggers configured on subscriber actions, such as a usage quota being exceeded beyond the threshold. So as soon as the quota is exceeded, an upsell offer could go out to the subscriber. In highly competitive markets, we see that porting numbers between operators is a challenge both for the incumbent as well as the existing operator. So we have use cases where an intended port out request can be captured at the time of the intention, and a marketing campaign such as a recommended win-back offer could be used to reach the subscriber. You could have a location-based service where if a subscriber gets near a particular store, which is having a seasonal offer or an offer specific to that subscriber, this subscriber would be reached out through an advertisement, either directly pushed to his mobile, and at the instant when the subscriber is nearing this location, so that the location relevance as well as the relevance of the time at which the subscriber is targeted increases the probability of a conversion significantly. Similarly, for cases where the operator needs to know how to optimize its Wi-Fi upload patterns, as the operator detects a drop in the QoS through the network stream, an application can recommend a Wi-Fi upload to the subscriber so that the subscriber sees a seamless data experience. So in such cases, we generalize this to call it tripwire marketing. So we could have more sophisticated cases where an aggregate of usage, for example, is monitored over time, and if this aggregate usage drops below, let's say, an established average, below a certain threshold of the established average, then an offer could go out immediately. Whereas in an offline system where this data is pulled into a big data system, and then an analytics engine detects that such a trigger had happened in the past, by the time you reach out to the subscriber, it may be too late to act upon that subscriber. So in short, real-time recommendations that are event triggered based on subscriber behavior, we see have got 10 to 15 times the response rate than mass marketing. This is an established study by Gartner. And now let's go to the Flytxt platform itself and see how fast data and big data connect. Next slide, please. The Flytxt platform is a high-performance carrier-grade platform. This slide shows us primarily two paths. One is the fast data path, and one is the big data path. Between the subscriber, the channels, and the telco business user, and the data sources. So if you see the block above, it shows you the real-time trigger engine. This is where streams are plugged in to an event filter, and through a trigger detector, interesting events are identified. So when an event of interest occurs, a real-time rule is triggered. This is where we look up a fast data store maintained by VoltDB, and then like Ryan said earlier, the triggered rules match an existing insight from the subscriber. So you could have a long-term insight for the subscriber which says this subscriber is likely to churn and needs to be watched. That could be a long-term insight, and a short-term insight would be, hello, this subscriber has made fewer calls today than the average calling pattern. So the trigger as well as the learned intelligence about the subscriber are matched together to build an offer for the subscriber, and then goes through the subscriber's preferred channel to the subscriber. On the pure big data path, we have the data source feeding in to a continuous insight engine. This is the block you see below. This is built on over Hadoop 1 or on YAM. And this runs the long-term analytics about the subscriber. It holds trends for subscriber actions, of what the subscriber was doing on a particular day, what call was made at what time, what were the standard set of URLs browsed in a particular period of time or at a particular instance, and these trends for the subscriber are then collated together by an analytics engine which runs standard data mining and machine learning algorithms to do one of four things. It could derive a KPI, a key performance indicator, which for that subscriber, which would say this subscriber has a $10 average revenue per day. Or it could derive an insight about a subscriber saying that this subscriber is very likely to churn in the next 7 days. Or it could derive a recommendation for that subscriber saying that, hello, the next time you see the subscriber looking for a movie, these are the set of movies that you should recommend. And actions and rules that are relevant to these subscribers. So these long-term insights, which are derived from the big data ecosystem, are stored in the warehouse. And as I described earlier, the way the long-term insight is connected to the triggers is through triggered rules, where when an event comes in through the fast data path, the big data path provides the existing intelligence, and the marketeer defined rule serves the subscriber and advertisements, for example. The volumetric on the right shows an example of a comparison of what one can achieve with this combination of fast and big data in a real life use case. So a deployment that we have done using a Flytxt solution with VoltDB has 200 million subscribers, seeing 20 subscriber events a day, which amounts to about 4 billion events every day. Of these, only 10 million events are actually of interest, and the key is to derive these 10 million through the fast data, big data combined paradigm, and to send out these offers, send out relevant offers actually in real time. If we compare it with known so-called big data platforms, which like Facebook or like Twitter, Facebook and Twitter have far fewer subscriber events per day, and the ratio of real-time events per day per subscriber is far less. So the point I'm trying to make is that communication service providers, telcos, have a far higher requirement for volume and velocity than traditional big data platforms, and a combined paradigm for fast and big data works best in these cases. Next slide, please. So here it describes in detail the workflow that I went through very briefly in the previous slide. So a real-time decisioning workflow would be like the first instance, or the first step is sourcing the data from a BI output or a file or an actual network stream. This gets processed through an event filter, and the event filter looks up a real-time rule to test whether the event is to be considered as a possible trigger. So in step 2, a message for that event is built and passed on to a trigger detector. The trigger detector uses again a real-time rule to look up to decide whether the event that was passed qualifies as a trigger. In step 3, you see that the qualified triggers are passed to a rendering engine, and they land on a triggered rule. These triggered rules are a description of the possible trigger actions that need to be taken for a certain decision. And these look up, as in step 4, a data warehouse which has a repository of the KPIs, the insights, the learned recommendations from history. And in step 5, you see that the subscriber connector decision is made. That could be an optimum channel for the subscriber. These decisions are made here. Priority for what subscriber should be sent what message before before another message. So between 2 campaigns, you may have priority of one over the other. Those priorities are decided here. And then in step 6, the network is given the trigger in order to send it out to the subscriber. Next slide, please. So in the other use case, trying to relate it with what Ryan said earlier, the other use case is for a request response use case for fast data. So here I've just built a sample use case which demonstrates how a request response works. So here, let's say a subscriber is asking for a recommendation on, hey, let me know what interesting movie has come up for purchase next, or you land up on the operator's landing page, and the operator wants to display the next best suited content in terms of interesting offers or interesting images, pictures that a subscriber may want to see. So, let me just go into a little step-by-step working of the process. So a subscriber action comes in. Subscriber either opens a URL on his browser, and then that is step 1. It lands on the IR connector, which then detects that this is an event which needs to go to the event filter. The event filter looks at the event coming from the subscriber, and through a real-time rule processing decides whether this event could be of interest. So if you're looking only for, let's say, a subscriber sending a message to a particular IVR or a particular shortcode, then this is where the filtering gets done. And then this event filter passes on the message to a trigger detector. The trigger detector and the triggered rules, the lookup in the warehouse for pre-computed insight is primarily the same as the other use case. What is different here is that the trigger rule also says, okay, this is the communication that needs to go out to the subscriber. So it builds the communication for the subscriber. In case it is a set of recommended movies or recommended content, then this is what it pushes to the I/O connector so that this can go back to the subscriber. So this is like if I may describe this loop, it is a request coming in from the subscriber going through a rule base which contains both long-term and short-term insight, and then goes out as a response to the subscriber. Next, please. So we have seen the two flows for the Flytxt platforms enable the marketer. I just want to describe a business use case, which is through customer lifecycle management programs using real-time customer engagement. What kind of achievements we have made, and what kind of volumes we can expect to see. So the problem statement given to us was that we need segmentation to be done in real time, tracking for the subscriber to be done in real time, fulfillment, that is service provisioning for the subscriber to be done in real time, and the solution that we built also needed a comparison between real-time and non-real-time campaigns. So if you see the figure on the bottom left, you have a comparison of real-time versus non-real-time campaigns, different types of campaigns. So the first one is where usage is dipping. So subscribers' usage is dipping, and you can see the blue shows a real-time use case enabled by Flytxt, the conversion rates, and the red shows a non-real-time use case. So in the case of dipping subscribers, we see that we can reach a conversion ratio which is over 20% higher than that of a non-real-time use case. Similarly, there are zero usage subscribers. There are subscribers who have multiple SIM cards. So this is extremely popular in very high and very dense markets like Kenya, like Nigeria, like India, where the subscriber, where the operator wants to hold the subscriber on to his network and not want to switch to the other network which is available readily on the subscriber's mobile. So in each of these use cases, you'll see we have demonstrated that real-time campaign conversion rates are anything from 20 to 40% higher than the non-real-time case. So if we look at the impact generated, which is on your screen, which will be the bottom right, we are generating almost a 1.2% incremental revenue month on month for in this use case for the operator we discussed. 40 to 300% higher conversion rates for real-time on-trigger campaign yields. The customer experience response time to customer events has been reduced from 24 hours to 30 minutes. That is typically a subscriber makes an action today, the response from the network goes out the next day. Whereas with such applications, with our application that Flytxt provisions, we can reduce that to 30 minutes, within 30 minutes of the subscriber's action being done. And the target customer base has clocked a net ARPU growth of 18.9%, which is which if you compare to a typical case, which is about 4 to 5%, is what the market here typically targets. The system specs are as I had described in the previous slide. We have about 10 KPIs which are real-time KPIs. We have 1.5 billion rows at a data frequency of 5 minutes to 24 hours, and we are running 250 odd campaigns every day. So we are making 1 billion updates for the KPIs for every subscriber every day. So this is a tier 1 operator in a developing market, and you can see how the fast data has significant advantages for the market here. So thank you, and I thank you for your patience and listening to me and Ryan, and over to you, Peter. Thanks.
Thank you, Prateek. That was awesome. We really are excited to have Flytxt on hand to be able to talk about the business value that you've been able to create and the role that VoltDB has been able to play in that. Some of the numbers that you covered were just incredible, and I think showed the value. We're always out talking about how these streaming applications, they're really database applications as long as your database is fast enough to support the use case, and you've really demonstrated that today with lots of impressive numbers. The fact that you guys are processing 4 billion events per day, which is on the order of magnitude of what these huge social media platforms like Facebook and Twitter are producing is incredible. $350 million of incremental value created by Flytxt. And terrific to hear you explain how you use VoltDB for real-time triggering to really make the platform that you provide smarter, better at optimizing recommendations, authorizations, and customizing the user experience. That's terrific. And certainly to anybody that's listening to the webinar, Flytxt and VoltDB would be happy to talk to you about how we could help you achieve similar numbers. So with that, we're going to conclude. If you have questions, use the chat window to type in your questions or send them on Twitter using the hashtag VoltDBFlytxt. If you'd like to learn about Flytxt, check out their website. If you'd like to try VoltDB yourself, feel free to download it off of our website. You can try the Enterprise Edition, or you can try VoltDB in the cloud. We've got it set up with Amazon's CloudFormation to make it easy. And VoltDB is also available as open source on GitHub. So with that, thank you for attending, and look forward to your questions.